Something happens or not happens. Student, ein Stück.
Они всегда опаздывают, что ли? Если я опаздываю очень быстро.
Это люди, которые не знают, что есть время.
Просто меня будут с станции спрашивать, сколько, когда ты сможешь приехать.
Так. Not know. 2 Stück. Так. Not know. Not know. Нус. So, как говорит. Шпанунг. Шпанунг. Конечно. Так, я не понял, а что такое? Ага. Так. Тутум, тутум. Yeah. Yes. I should answer yes.
The question, how to succeed in design of substations? No, like in this field, how to be like successful? They need to just learn this like types of substations. Different
First, okay, you need some knowledge, equipment, and so on, and then practice. Practice in some design team. Because you not only need to understand how to place equipment, how to design currents. One of the key element in all this business is not doing what you think you should do. Do what your customer like you to. And the most problem, you need to sell your design to customer. Because in most time,
to win the tender.
no, it's a question of your bosses. We have client want this and this. You need to, the key art in this area is to sell your vision to customer. Because customers are greedy and stupid. Okay, where am I?
Scientific assistant sounds like very.
It's a practice. One of the most thing needed is a practice to get all approvals from. See, when you in real construction business, before you can send the digger in, you need approvals from landowners, networks, communication companies, local legislation, blah, dozens of them. Best salaries are for guys who can get all these coordinated, get all approvals, coordinate with customer representative, coordinate with equipment manufacturers.
But like, what is the salary for this position average?
For starting, 1,000 in in pure, in reality, in your pocket. Lead designer, project leader, 5 to 15 grand, something like this.
It's part-time.
It's full time, and it's consuming leads of actually. System works like this: we have the design order from someone. Our bosses got top bosses, owners. Owner takes quarter. Next quarter of the remaining is for team leader, for lead designer. All remaining for monkeys.
For junctions.
Monkeys. Oh. See, Latvian design, all this design project business is quite small. Money, people working on international market. Now it's not here. It's not a very good time for this design. How to say, plants, factories. Not much construction happens. Okay, where is my... Something went wrong. I need to push this. Devices. Where is my devices? 1 second, I will... Save course. Okay, do something. To do or not to do? What I got for today? My sleepy students. I have an example of device on my table. This one, nice box. It's an example of intelligent electronic device. It's a protection device, multifunctional protection device, and it's example of how to say. There are two approaches. One minimalistic approach, only necessary any how to say decorative unused element is a threat to safety, threat to stability. So in case of minimalistic approach, only function needed. If we speak in terms of IT industry, BSD design, most functional, most minimalistic, nothing more, and on very this minimal code, but with very deep debugging, very deep testing, very reliable. But virtual no visual points of sale, very minimalistic design, very minimalistic service. On the other, how to say, and full of nice decorations, nice large display, nice buttons, all kind of function, web interface, Wi-Fi, all this blah. Not needed is a weak word. Not needed. It's a cancer. Web access means lack of security. Not needed. All these nice features like nice displays. No one on substation, no one to see them. They are no, in my view, it's just waste of money. But device should sell itself. Also, design roots. If your designer, how to say, core of your design team is rooted in the 80s, in the minimalistic and slim designs of the 80s, professional design aimed exactly at power system automation. It's one story. If your team is rooted in universal industrial controllers, it's a second. And if they are rooted in something modern design of gadgets, it will be third story. Team designing gadgets should design gadgets. They should be kept away from power system automation because they are oriented. They have center of gravity of their mind in visual effects. This should be nice. No, the first thing we talk in power system, it should robust. It should be bulletproof. Situation when your device restarts silently, periodically, which is avoided by some company. I will not point my finger because I don't want to also it from them. It's an absolute garbage. Okay, let me show this nice device. I like some thinking it's I really why some not. Okay, 1 second I will. Oh. So as I said, device very slim basic design. What we have in user interface on device itself? Small LCD display and set of programmable LED. You program them to indicate what you from choice. Protection operation, I'm okay, and so on. Here, what can I do? I can check settings. I can activate here live measurements. Second, I will bring second camera. Here it is. I have voltages here. So, voltages with the angle, magnitude angle, currents, I don't have any currents at this moment, zero sequence voltage, direct sequence voltage, state of the switch, auto reclosing, settings group. This device allows me to have 4 setting groups switchable by external binary signal. when configuration of network change, I don't know, line connected, disconnected, you don't need to, okay, let's be less correct. Your personnel in place, maybe, how to say, low competence personnel. Allowing them to change all settings is stupid. It's risky. What you're doing, if you understand what your substation can operate with one line or two line, with one transformer or two transformer, you create set of settings, and the activation binary signal device received binary signal settings group to use. What you do, you put a nice switch on the panel, and your personnel, if you disconnect line 1, put switch in position 2. They don't need to think. They don't need to go through all settings array. Simple, change a switch. Okay, speed up. Only basic knowledge about present state of terminal. Activate it with one button. Settings, I can go through, and what else? I can see time, I can see settings groups, but I cannot change anything without entering a password. It's a protection, it's a mandatory. For one more thing, for devices sitting on very important networks, good practice is know what to do, is to employ hardware lock. Until if person needs to change settings, it goes to the security service, takes a hardware lock key, signs in journal, put key, change settings, return key to security officer. Records remain, key was taken. Understand why? Yes, for state security. Okay. Is it needed? Actually, even this display is not needed. You can have only one LED operational. All service go to computer. This device has a very basic communication port, RS-232. You heard about this protocol? Yeah. Serial communication protocol. Where are you? Where is my 1 second? Oh, here it is. Proprietary communication software. Hey. Will you start? Here it is. Two of them. I need only one. Okay, here it is. Old C copyright 1994 11 it's. Actually I need to compile flash version. Again, very basic interface. First, what I have? Local time and ability to select device. I have a list of devices. I don't need to think what the device is. I just select one from the list, push connect. And what happens? Loading settings from device. On any connection, this system, it's robust, reads setting device and stores it. if something was altered, something changed. I have list of device settings. I can trace back what happens. I knew what should be state of my device. Next one, look what appeared. Events list. Necessary thing for such kind of devices. Each action, voltage appeared, the protection started, protection tripped, settings change, anything, triggers and event. To understand what happens with device, what's going on. What helps me? Events. They are stored in non-volatile memory. Even if device dies, I can take memory board, put it in another device and read events. Here, this device gives me 10 events. So here, date, name of the station, device, fault of the switch circuit. Device has a monitoring for the state of its switch. If we receive binary state not allowable, both 1, both 0 and so on, it triggers an event. Power change. Connected, disconnected. Device power supply has ability to power device for some 5 to 10 seconds after power disconnection. It's done to save, even if operation power dies, device will save event and maybe, if possible, sends a trip command. What else? Operation, fault. On each connection, events are added. Oh. Events are added to local history. I can trace. Device memory isn't infinite, but I have local stored history of events. This allows me to understand what happens in case of misoperation. Okay, what can I do? I can print them. Next one, object, time. It's crucial to have a local clock on device because you need it. Even if device operates standalone, there is no bilateral configuration like in differential protection. Anyway, I need time to understand what happens when. In case of system emergency, system fault, what will I do? I need to build big picture of events. What happens? To build a picture, I need an uniform time. Without it, it's bullshit. How time works here? Device has independent clock with battery power, with its own battery. To synchronize it, when I connect PC, it can be disabled. Time, where is time sync? Time, yes, set time. should be automatic. Yeah, completed. So on each connection, time is synchronized, but that's not all. Time setting from remote PC, it's not enough. I don't know when someone will connect my device. And this not ensures time discipline. This device uses older approach. It has one binary input. Time discipline. On substation, central clock should be installed. Central clock sends a pulse, 1 per minute. And this pulse zeroes second counter on devices. It's an old approach. A new approach, via local network, time is set using some of the precise time protocols. Like precise time protocol, some use NTP. Here, actually, if you have a lot of this device, you can use this nice guy. It's a centralized system which calls all device, talk to everyone. And computer clocks are synchronized using network time protocol to central office. And Pure keeps all clocks of this device synchronized. But it's an old approach. Now, how to say, tradition, mainstream is to use a time signal from global positioning system. IRIC-B signal. It's very precise, appears very reliable. It's very reliable until moment someone brings military GPS jammer in vicinity of your substation. And hell opens because military civilian jammers only block navigation signal, but military ones send fake IRIC signal. Your clocks will show anything from Ganaula time to Venerian or Mercian. Okay, we live in bad time. Next, service of device. If you saw connection, okay. Now clocks are synchronized. What's in here? My software talks to me. Here again, it's a skeleton device. You see log all time, but it's all recorded in file. More, how to say, more nice, do not show it, but they always should write all activity logs. Why? Again, in case something happened, it's forensic. Okay, what do we see? I can get it. Again, events, records. My device has built-in recorder. For any event, something happens with the binary signal. Something, protection starts, protection trips. For anything, it writes a state of its signal. I will open. For each record, I have what? Its number, start time, start date, why, reason of the start, why it started. I can get one. software, I see all my signals all analog signals, there is nothing creates noise, all my binary signals. No. If I like, I can force start of device. Activation complete. Okay. Why this service is needed? I'm sitting in my office. I would like to know what's going on, what happens. I send start command and I'll get device start. Okay. Was nice glitch. Actually, I need to watch. Need to watch memory. Directory. This device has round robin memory. In common device, what happens if memory is full? You receive message, oh, memory is full, free some memory. Yeah? This one will write around. Operation is paramount. So if there is no free memory, all these records will be overwritten. Operation is paramount. Yeah, here. You see? Come here. PSP PowerShell force start. I send start command, device completed. Yes, very good. Okay, it is. I took a snapshot. Now voltages are touched, so I have snapshot of my voltage. I have snapshot of my signal. I can take it anytime I need. First, of course, it's state of my device, binary, but it's also allows me to diagnose what happens at my substation. If I need, I just I activate my diagram. A signal. Oh, now watch one moment. You see a red cursor? Right. Oh, this one. It's visible. Yeah, it's visible. Not in the best quality, but it's a time marker. Fourier transform filter takes one period before mark. You see diagram rotates. Why diagram rotates? Why moving the cursor diagram rotates? Time frame of DFT slides through the signal. It's the same like let's say I'm moving zero of time scale. By moving DFT frame, I'm moving zero of time. That's why on each click I will get in a different initial state of the vectors. Actually, I need please, okay, set base image. Without, hey, come on, let me put this window. Without pegging, without setting base vector, diagram rotates, all measurements are rotate. A result of discrete time Fourier transform filter of your orthogonal components will slide in time. Remember it. Okay. Nice snapshot. No, I don't want it. No, it was. Here's substation. Yeah, it's direct communication. Actually, I don't remember what it can do. In designer mode, it can decompress. One more moment. Because decompression mode. Because communication channel, in this case, are limited. Data is stored in compressed form. One of the tiny moments this device sends files in kind of impulsive compression. I need tiny thing, but it helps. Why helps? One of the moment memory is cheap, yeah, relatively. But this device cannot use DRAM type of memory. It's not safe, it's not robust enough. It uses static memory, much more expensive. Okay, what's next? Device allows, okay, it should be in tools, yeah, monitor. I can take a look what's going on anytime. I don't don't need to go to device and push buttons. What happens? Measurements are available for me anytime. Easy, easy, but it's so helpful. I can understand easily. I can get state of all inputs and all outputs anytime. Simple service function. And what's here? Synchronize sort. I don't care. Carbon copy I can get. What's about settings? Okay, right. Wait. Seconds to raise my setting editor. Yeah. Yeah. Here is my settings editor. Good old settings editor. Mistake in settings may mean disaster. So, what do I have? This one strange don't have groups. Okay, I can define it. Okay, at this moment there is no group. Oh, here I have appear a row list of all device settings. For example, this one, functionality of distance protection. For each, I have description. If need, I can add custom comment. So for each IC description, inductive resistance for line to ground fault in ohms, and IC value and original value. Why? Strange thing with Scala. Here should be for example 19. Is not. See what happens. I changed value and it indicates with Scala and T. I did actually, I'm editing file. I'm not editing the settings at device. I can select update. It will replace original with Scala. I can place a reset and I will go back. It's undo. Why it's done this way? To prevent faults. To prevent human faults. 4000. Auto reclosing. Here, for example, binary words. And for, see, I have, for binary, I have chosen for analog values, description and ability to change in steps. For binary, I have drop down list. Here should be comment. Where I can custom comment. Okay, I can add comment which one I changed. Change something. Settings. Nice editor. Oh. You see, it's tiny idea of fault prevention. Now, what can I do? Active resistance. Giant block of distance protection. Save, yes. What happened? I saved file, but I changed nothing in device. If I like to change device, I go here. Look what happens if I try to write file from another device. Oops! Safety. Settings files are not interchangeable. Again, I need to authorize operation. It's one, and second, settings files are coded. They are linked to device. You cannot, oh, okay, I wrote settings. You cannot write settings from one device to another. This I saw many times when devices don't have this safety lock, where misprogramming. Engineer just mistaken writes settings file to wrong device. In events, check for it. Events, setting change. Again, it's a safety function. Maybe we can try. Oops. I will get timeout. Okay, maybe maybe I can try to get this monster here. It's a poor. Of course, it's nice to control devices by hand, yeah? But much better to do it automatically. In the set, poor king. What's mean? This software runs silently, and it go by scenario. Let me see. Oh. I may have dozens and dozens and dozens of substations. This thing runs by scenario. For each substation, I add, of course, its name. It was intended. It's from the time that phone modems were used. Remember, what once phone lines were used for internet access, for data transfer. What talking? It's from times of dinosaurs. So this thing is working. Its design roots in times where phone line were used for access. If I have direct network, I just select direct, and it goes. I can specify position devices at position, not on a recorder, any device. See, on substation, we need to somehow distinguish our device. Each device should have local address. It may not be IP address directly. Anyway, TCP IP access requires network controller and so on. These devices are simple. Device itself has its local unit number, and TCP IP adapter or access device is for one or group. At position, if needed dedicated port, what to do? I have scenario. Block, 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 block. Okay, maybe I can remove this one and remove this one and say done. Oh, now it works. What it's done? It connects to device. Again, reads settings, saves events. You see, all time pull, just pull these events. It saves events locally. Reads all list of records. I need to push this device memory. And it starts to pull all files from device, all records. It's alive. It's kind of crawler. It will try once more and more until it gets all records from device. But records are not erased. They only mark. They have flag new old. there is in this system, see, in case you download, theoretically this record is no longer needed and can be trashed. No, here any user gets all records available. You cannot erase record without special command. Again, it's done for safety reasons. Okay, crawler will attempt to get copy of device memory, but it has a quota. I don't remember 16 at the time. It's programmable. It will get quota and move to another. It's done to prevent stick to particular device. It will try to sniff all devices. At morning, this thing can run all night. At morning, no question where it's. Should be somewhere here. Oh, yeah, records. I see records, but where? Aha. What they? Here is my substantial. See, records sorted in time, events stored, events stored, records stored, and should be one nice events stored, should be also activity. One moment, it should also write I can specify where it should write one large activity file, but where it is should be somewhere. This is not activity. Oh, templates. This is Right. It's much easier. Come on, I want to change from EDT to TXT. Yes. It's a text file. Oh, it's strange encoding, but it's I can see all what happens with my device. Operation of distance protection. All here. But also, this puller creates a log file records and events. Crawler. Crawler goes by scenario. Crawler is a nice thing, yeah? Every morning you can check your computer and get all what happens overnight. But that's not all. Yes. This interesting thing. It's a super crawler. It's a kind of spider. This program launches multiple crawlers. When your system grows, you would like to pull this substation, this substation, this substation. It's kind of a squid. This squid launches multiple crawlers and controls them. It sends crawlers to you go there, you go there, you go there. Inside it has scenario. Actually, it's one scenario, one large scenario for all crawlers. This thing takes a bit of scenarios and send next free crawler to execute this string of scenario. Here they are conflicting because I have only one device. If I have multiple devices, this thing will spread jobs and crawlers will pull all my system. So Squid is a super crawler. Manual control, crawler, and super crawler Squid sending crawlers all over the system. Should be nice to open device. I need one disassembler. Funny, yeah? They are fighting for single communication channel. Nice, simple device. Maybe. And what if this is number 2, and what about number 1? Yeah, number 1 operating this one. Give me a chance. Okay, I can kill all of them. Oops. Super crawler, when it's written. There's no copyright. Should be. Crawlers. Okay. In my view, it's required basics of functionality. All above it, it's optional. In theory, what can be? I don't said I don't. What I don't. I should when it was available, I should grab one example. Two-level integration. Device like this previous model was able to read data from 4 fault locators. It was two-stage system. Like, wait, this disassembled one. Here it is. One disassembled one. 4 of them, up to 8, but I only saw manufactured version of 4. 4 fault locators, in case they detect fault on the line, they calculate fault distance and throw data to central unit. Central unit pulled by crawler, and I got in events fault distances for 4. It was 110 kilovolts line. I have fault distances for 4 line. S1 even. Or 4 evens. No, each one separate even. Boom, 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 boom. And if I kill one, yeah, really good. Oh, walk it on register. I can revive the weight. Nice tiny. It will pull all the memory. Kill everyone. I love this button, kill everyone. Okay, what I no remote time, no remote date. Settings, list of events, list of records. Oops. Crawler worked. You see? A result of crawling. Crawl, sucked all these files, and they are in state old but not erased. I can get them anytime I need. Can I push memory? push memory. Oops, don't like me. Don't tell me I provoked something. Oh, okay. Okay, completed. Oh, force start. Yeah. Give me file, come on. Yes, give me. Here it is. Oh, our network symmetrical. Yes, our network is symmetrical. Change scale. How do you think? What IHE changed? What's the difference between I, H, and E? I, instant values. H, on the base of first harmonic. And E, effective or RMS. It's needed. It's needed because you never know what you're looking at. Effective. See moment. 55.7, 55.66. It's same voltage. Why is the difference? Device. I change. Here are recording points. Device recorded in step 1 millisecond simple points. Effective is an RMS calculated on the basis of 20 milliseconds. This one, result of discrete time Fourier transform to get orthogonal components. Why I see difference? If voltage would be ideal voltage, pure sine, they would be equal. But voltage is taken from network and it's contained what? It has offset 0.4. Interesting. Tiny problem. Signal has offset 0.4%. And small presence of second and third harmony. Most this one. Interesting. It has fifth harmony. Voltage isn't ideal. Effective takes into account all harmonic components, while on the diagram for only 50 Hz component is taken. That's why you see this difference. Actually, both zero and second harmonic, it's imprecision of device. Fifth, maybe. Okay. No, I don't want to save any changes. Barbarian. Okay, saving my nice voltage. 55.7 effective and on base of harmonic and same instant. Nice toy. I can also ask for symmetrical components. Eh. Diagram. Who can explain why I see negative sequence. .88 direct sequence. Why I see 2 volts of negative sequence? Volts of negative sequence and go in precision of DFT. Actually device, by the way, I'm not 100% sure what I have an absolute symmetry. Look here, 55.7, 56.4, 52.7. Network isn't symmetric. Transformer. It's because of transformer. I see. Nice example of basic service. Come on. Machine, come on. Oh, yeah. Mm-hmm. 1, 2, 1, 2. And one second. Yes. Attendance chart saved. Okay, I can